1.4 now, examples on complex numbers. So let's take a look here. These are just quick run-throughs. You pull them out. If you pull that out, that's an I. Remember, whenever you have the square root of a -1, that's an I, and the square root of 49 is 7. So that's a 7I. Pull that out, like I said, that's just an I. So whenever you have the square root of a -1, that becomes an I. Square root of 27 you can separate into root 9 and 3, and the square root of 9 is 3, so it's really a 3I, root 3. Over here, pull out that. Remember, square root of -1 is an I. Separate that into 4 and root 32. Separate 32 into 4 and 8. You can separate 8 into 4 and 2. And the reason why I did this is because that becomes a 2, and that becomes a 2, and that becomes a 2. So really I have I times 2 times 2 times 2. And a root 2 in the end. And that actually gives you 8I root 2 as your final answer. That's just making your normal root tree the whole way down with all the multiplication factors of it. Alright, so we did some examples like this. These are the simple ones, right? 4 plus 2 is just combining like terms. That's 6. -3i's and an I, that's -2i's. That one's done already. 3, we're going to take that negative through to both. So really 3 minus 6. It's 3 minus 6, that's -3. -5i minus 2i, -7i. This, because it's multiplication, it's like foiling. So 6 times 3, that is 18. 6 times -1, our I is -I. -5i times 3 is -15i. -5i times -I is +5i squared. Combine your like terms. -6 and -15 is -21i. Now you got to remember that I squared is also the same as -1, right? So really this is a -1 times 5, which is -5. So what's 18 minus 5? That's 13. So it's 13 minus 21i. A 3 minus 2i squared is like saying 3i, 3 minus 2i times 3 minus 2i. So 3 times 3 is 9. 3 times -2i is -6i. -2i times 3 is -6i. -2i times -2i is +4i squared. So you combine like terms, -6i and -6i is -12i. And this I squared is the same as -1. And -1 times 4 is -4. So 9 minus 4 is 5. So you get 5 minus 12i as your answer. I to the 102. Okay, remember I squared is -1, I cubed is -I, and I to the 4th is 1. So let's see, how many times can 4 go into 102? It goes in 2 times with 8 there, so it's 22. Bring down that 2, so goes in 5 times with 4 times 5 is 20, with 2 left over. So what that means is 4 times 25 is 100. So I can write this as 4 to the 25th, which is 100, and I'll have 2 left over. Well, if I to the 4th is 1, so it's like saying, I have 100 times 2, that's 102. So that's why I wrote it this way. It's like saying 1 to the 25th, which is just 1. So 1 times I squared is just I squared, and I squared we know is -1. So basically all of this is just -1. Okay. Right, because 1 times -1 is -1. This, I can rewrite it as 4 squared because I know I to the 4th is 1, so it's like 1 squared. So this is actually 1. This I can rewrite as I to the 4th and I to the 3rd because I to the 4th is 1. And this is -I. So really I'm looking at a 1. I'm looking at a -I. And this I can rewrite as I to the 4th and I squared. Well, this is 1. This is -1. So really I have a 1. This is -I, and that's a -1. And 1 minus 1 is 0, so really I just have a -I. All of that was just a fun way of saying -I as my answer.
Pizza, pizza.
And to solve a problem like this, since it's quadratic, let's put it all on one side. So I'm going to minus 10. And there we go. And I can divide by 3, which gives me x squared equals negative 12. And the reason why I move this over is because there was no x's there. And I square root it, but I square root a negative, so what happens? Well, when you square root a negative number, I got to pull that out. So square root of negative 1, the square root of 12. Square root of negative 1, if you remember, that's I. So it's I root 12, and now I need to simplify root 12. It's root 4 and root 3, and the square root of 4 is 2. So really my answer is 2I root 3. And don't forget, because you square root, it should be plus or minus there. Plus or minus 2I root 3. So I have the positive there. It should be plus or minus. 5 times that negative 2 is negative 10. 5 times I is a 5I. Down here, FOIL, 7 times negative 1 is negative 7. 7 times 2I is 14I. Negative 4I times negative 1 is positive 4I. Negative 4I times 2I is negative 8I squared. So 14I and 4I, that is 18I. And I squared we know is negative 1. So negative 1 times negative 8 is positive 8. Negative 7 plus 8 is 1. So it's 1 plus 18I. And remember when they're opposites, right? This is the same thing. So this is addition, this is subtraction. Just take the first item and square it. That's 36. Take the second item and square it. But this is me showing you just FOIL it. If you FOIL it out, right, these two middle terms cancel. And negative 1 goes in there, which is why it's 36 plus 9, which is 45. Or if you remember the formula, 6 times 6 is 36. 3 times 3 is 9. You add them to get 45. Either way, whether you remember that or not, you're still going to get 45.
There's only one right one, baby. You got the right one, baby.
And rationalizing the denominators, in this case, we want to find the conjugate. So when we're doing this, I do 1 plus 2I on both the top and the bottom. So this is what it would look like. 5 times 1 is 5. 5 times 2I is positive 10I. 3I times 1 is 3I. And 3I times 2I is 6I squared. On the bottom, 1 times 1 is 1. 1 times 2I is 2I. Negative 1 times 2I is negative 2I. And negative 2I times negative 2I is negative 4I squared. Those cancel out. Those I can push together, make a 13I, and I put a negative 1 in everywhere there's an I squared. So when I do that, this becomes a negative 6. This becomes a positive 4. 5 and negative 1 is negative 5 and negative 1 is, 5 and negative 6 is negative 1. 13I on top and a 5 on the bottom. So, if you have any other questions or concerns, if those examples went by too quick, once again, please remember, pause it, rewind, go back over it, okay?
There's only one right one, baby. You got the right one,
So,
baby.
please keep that in mind.